I want to look at a first order circuit, but now also looking at it where I need a Norton equivalent sort of structure to figure out how to solve this. And so again, we're looking at a first order circuit. We can see this because we have one capacitor, and the sort of state variable will be right along this whole V out node. Now, for those who are looking at this carefully, you're realizing this looks very similar to saying, what would it look like to have like a transistor that has a cascode configuration on it with some sort of load resistor. So pretty typical thing you might imagine seeing. And so you look at the circuit and you think, okay, how do I approach this? And what you realize, I've got this capacitor here, and so what I really like to do is have some sort of Norton equivalent looking backward, right? Because then I could get an effective sort of a current source here and effective resistance. And you think that would be great. Now how to do that? Well, certainly I see RL, and that gives me part of it, but then it's going to be, what is the effective resistance looking back further on this line? The RL is pretty straightforward. The question is, what happens for all the other things here? And obviously for those who've thought about transistor circuits before, this is a cascoded sort of current, so it works out in a fairly straightforward way. A couple of things that we would know from these kind of structures. If I look at this equivalent structure here, one is that its equivalent current, its effective current for the structure, is going to effectively be almost identical to the input current. And so one thing I will find is the effective current will be IN. And so that makes it pretty straightforward. Now there's a small change depending on the size of GS related to R2 and R1, but in this case GS is effectively a conductance that is a lot larger than the conductance of R1 and R2, so it's actually pretty straightforward. The other part of this circuit would then be to ask, what is the effective resistance? And in that case we would turn off the current, and we would ask we would kind of look into this structure. Well, what we would notice is we'd say, well, how much does, if I change this voltage here, how much will it change V1? And what you'll find is that number is a very small number. Pushing that all the way through, what I find is that effective resistance is going to be GS times R2 over R1. There's a couple different ways that we've solved these kinds of questions before, so I'll just kind of like leave it to that conversation. But it is going to give me an R1 times a GS times R2. So I'll have this one in parallel with RL. And you think to yourself, well, that works out fairly smoothly. You would have initially thought, well, look, I've got R1 and R2. Those are both 100 kiloohms. RL is 1 megaohm. You think, well, that's, clearly the 1 megaohm must disappear. But what's really interesting is it goes the other way. Is that, in fact, because the R1 and R2 with this voltage-controlled current source actually changes what that effective resistance looks like to be much, much larger than the 1 megohm in the first place. And so as a result, when I look at the parallel combination of the two, I get 1 megohm. And so my effective structure is a 1 megohm resistor plus basically the input current directly. So that's where I would start when I put this with the capacitor. And you think, okay, now I've got a Norton equivalent circuit. I can immediately figure out what a time constant is because I've got the R and the C in parallel. If I wanted to think about this in an equivalent way, I could imagine just doing a Thevenin-Norton equivalent and ask, okay, well, what is the voltage source here? And what is the effective resistance that now is going to be in series? That voltage source, of course, will be minus R effective times I effective. And so I can think of it that way. And notice if I solve this out for the output voltage, which is the term I'm looking for, I'd have minus R effective times IN. And so I'm basically given the same kind of differential equation, first order type of differential equation, where I'm going to get the same sort of exponential convergence to a particular steady state value.